among marathon runners, 30% 50%, reported that their menstrual cycles seem to negatively impact training. The days at or around ovulation are generally considered the most accommodating and relaxed of the menstrual cycle for young women. The endurance performance of both trained and untrained women does not seem to be affected during these days. A study on 10 healthy young women reported an increased fatigue and slower relaxation and performance. However, athletes from other sports disciplines have reported no perceived change in performance, 62%. During menses, with 71% of the athletes feeling better during the first 14 days and feeling worse just before menses itself. Method. Participants were Division I collegiate female tennis players in Taiwan. Exclusion criteria were a menstrual cycle outside the range of 28 days. A total of 14 female tennis players were initially enrolled in the study, of whom 10 players, aged between 18 to 23 years, completed the study. Experimental protocol. All assessments performance-related measures, mood state, dehydroepiandrosterone sulfate were conducted for 2 complete menstrual cycles under placebo-supplemented and dehydroepiandrosterone sulfate supplemented conditions in a counterbalanced, double-blind, placebo-controlled and crossover manner. For each cycle, assessments started within 24 hours after the onset of menstruating bleeding and were tracked weekly thereafter. All participants consumed either dehydroepiandrosterone sulfate or placebo capsule provided by the experimenter daily for 4 weeks starting on the first day of menses. On each data collection day, participants for measurements of mood state, plasma, subjective fatigue, sleep, muscle strength and serve performance. Profile of mood state. A 37-item short form of the profile of mood state inventory was used to assess mood state. The 6 dimensions: anger, fatigue, depression, tension, confusion and vigor. Plasma. Fingertip blood samples were collected into pre-cooled Eppendorf tubes. Balance assessment. A force plate was used to measure balanceability. Each balance test lasted for 10 seconds, and the participant was stood on the force plate with their dominant leg. Muscle strength. Muscle strength in the dominant leg was assessed. 3 maximum isometric contractions were performed using knee extension, hip abduction and hip adduction. Tennis serve performance. Serve performance was determined by both accuracy and velocity. Accuracy was assessed using target scoring 1 or 3 points. Velocity of served balls was detected. After 1 minute of quiet rest, subjects then performed 20 scored repetitions with 30 seconds rest intervals. Results. The figure illustrates the scoring method for tennis serve performance. Increased plasma was not associated with performance scores throughout the menstrual cycle. When data of both trials were combined, the lowest performance score occurred on day 14 compared against day 21. The data from the separate trials showed a similar trend. The performance decrement on day 14 was attributed by decreased accuracy rather than decreased velocity. In the placebo trial, the isometric muscle strength of hip abductors and adductors, but not knee extensors, decreased on day 14, but this was not statistically significant. Postural balanceability of tennis players decreased marginally on day 7 and day 14 when data from both trials were combined. A small inverse correlation was found between tennis serve performance and the postural instability measure of balance when all trial and time point data were pooled.